Hello, hello. How are you? Good morning, good evening, good night, good day, good month, good year, uh, good season, good decade. Bonjour, bon venue, bon appetit, uh, arigato, namaste, pajalsta, hujambo. Yes, languages. That's what you're talking about. But not just any languages, like any of the ones I've mentioned. No, no, no. Different languages, computer languages. See, the same way you'd use those languages to talk to a fellow human? Computers also have multiple ones that can be used to talk to them, just in different ways. And what you're gonna do, you're gonna use two of those to tell the computer to do the exact same thing. You know what? To make a calculator, but not just any calculator, the arithmetic calculator. Mind-blowing. You know what it does? Mind-blowing things. You can add, subtract, multiply, divide. Imagine 4 functions, 4 whole functions. Ay. What a savior it is to many of us. Imagine having to do all that stuff on pen and paper. Dark times also. But those days are over. With this knowledge, you'll be able to enter any exam room with confidence and diligence of getting kicked out because you have a laptop in there. Anyway, let's start. 2 languages. One of them, go. The other one, lower. And we begin. First statement in the language go is that meaning package main of tix.go. It's a main package that basically tells the computer, this, what we are making here, is nothing else but just a main program. If we named it something else, it would be a library. A library can be used in other main programs. After that, all you have to do is say func main. What is func main? The entry point. Anything outside over here, the computer won't read. So don't even get your hopes up. Nothing will happen if you put anything outside here. But you know what? We're gonna do that. We're gonna do addition, subtraction, multiplication, and division outside here. But you know what? We are not yet done. Now we need to implement the syntax. If not, that wouldn't work at all. We just be writing text fancily. Syntax looking pretty good. So far, so good. But something is missing. You know what? Let's take a closer look between main and add. What's different? Yes, you guessed it. Parentheses. Need to put that for all of them. Each and every one of them must have what? Parentheses. You know why? Because they're important. Next thing we do the same for lower. But you know what? I'm not gonna write everything. Imagine doing that. Who was on that time? Not me. All you have to do now is change things up. Yep, that's not working. But these should be working. Now we have to implement the syntax for Lua. And in Lua, there are no braces like this to show that it's a beginning and the end. You literally have a keyword called end to show yes, it has ended. Nothing beyond this. Next, you need to add Sean to all of them. Function. That's a keyword to show that you're making a function. Yes. Function. Next, remove the unnecessary brace. And bam! The equivalent of what you have to the left is what we have to the right. Nice! Now, we actually have to start writing stuff that will actually get to do stuff, you know? Stuff. To begin with, we need to tell the user to enter something. You know what they're entering? They're entering a number. So you'll tell them this. In Go, you have to use another function from a package called foopt, something like that. FMT, yeah, the FMT package. And how do I know this is a function? Look, this is what gives it away over here. So in this case, what you're doing is calling a function. What you've done here for all the rest would be declaring a function. But when you call, it will be doing the stuff that's inside the parenthesis of this print function. And where is this print function? In this fumpt package. Where is this fumpt package? Part of the standard library for this, the Go language. Good. So when we call this function, we need to pass to it some things. To begin with, we need to say what we are passing to it. These are the things we'll be passing to it. X, Y, and res. These are variables. How do I know they are variables? Because of this keyword. In Golang, you have to declare variables using this keyword. Next, you have to say what those variables hold. And what they'll be holding in this case is float 64. This is just defining the range of those variables, what they can hold in terms of numbers. And this is how big float 64 is. Good. After that, what you pass into print as an argument, the stuff that you put into those parentheses when you're calling them, has to be the memory location of a variable. So you can't just put X. We need the memory location of X. In Go, how do we do that? Just the same, and you're good. And there we go. This line of text literally asks the user to input something. But now, the user will just hear a black screen, and they won't even know what to put. So you need to tell them, yo, you dude, input something. You know what to input. Enter a number for me, dude, or girl, or horse. You never know. You never know. And here I messed up. This is the wrong function I'm calling. Function I should be calling here is scan. Print, show stuff to the terminal. Scan, get stuff from the terminal. Let's just see how real this is. Remember what I said? What we write outside of main won't be executed. So what we need to do is what we did over here. We need to call it, but now we call it inside main. Having done that and saved, open up a terminal. Go to where your stuff belongs. Mine belongs in the folder Rexa because it's a cool name. Then I'll try to run it. Use this command to run the program. Go run. It will build and run. And as you see, 2 error messages. Nice. You know why? Because so far, it has no idea what fumpt is. So we have to say what it is. We have to import it. So that you can use all the functionality of fumpt. In here, we have to import fumpt. When you are importing in Go, you need these double quotes to surround the package that you're importing. Good. Do that, save, run again, see if it works. Why? Oh yes. Another error. You cannot just declare a variable and not use it. So let's finish this program up. We'll ask them to enter for us another number because we need to use those variables. Number, dude, or girl, or cow. You never know, man. You never know. After that, we need to get that number again. Give it the memory location of y. Finally, we need to do the calculation. Y plus x. After doing the calculation, we need to show them what the answer is. And what would be the answer? Now first you need to tell them what you're showing them. Your answer is, what is the answer? That the answer should be held inside res, so it will show the value inside res. Save that, run that. Another error. You cannot use your answer is type untyped string as type float 64. Incompatibility. So what I'll do is just split this into 2 lines. No point of cramming it into one. No point at all. So here it will print for us res. This will be together. Over here, yeah. So far so good. Finally, it has worked. Now let's enter a number, 32. Another number, 12.78. Yeah, nice. Nice. Working. Beautiful. Wonderful. Now, the fun part of all this. You're in for a treat. Copy, paste. This is actually how people go. Now, this is the good stuff. Ay. You're missing out if you don't do this. And all you have to do is just change one thing or two things and you're okay. Yeah, and also you need to change the order here because subtraction is not commutative like addition. Oh wait, this is division. Also, this is not commutative. Multiplication doesn't really matter how I put them. Final thing is, this should be subtraction, but what I need to do is change the order. Nice. And then, to top it all off, you need to call all of these. If you don't call them, they won't run, literally. Now, nice, all of them are called. But then, can you imagine having to add first, then you subtract, then you multiply, then you divide? Just for you to be able to divide an answer, you have to go through those three first. I can't imagine that. That would be sad. So let's ensure that doesn't happen. We'll make another variable. We'll call it selector. And selector will be of type what? Type string. String is just text. This stuff in blue over here with double quotes. This is a string. Yeah, type string. Then we'll use this control structure. Switch what? The switch statement. What are you switching on? You're switching on selector. And what happens when you switch on selector? Well, you just have to move this stuff inside. Now all this stuff is inside the switch statement. The first case, if selector, oh my, if selector is equals to A, do this. The second case, if selector is equals to B, do this. Third case, if selector is equals to C, do this. Fourth case, if selector is equals to D, do this. And so far so good, but then need to ask them first and foremost what they want to do before jumping to any conclusions of what they want to do. So, what do you want to do? Person or goat or cow or sheep or chicken? You never know, man. This world is changing so quickly. Just things are changing. Then you leave a space over there. Then you get their input, what exactly they want to do. Same function for getting the input. All I need to pass is the memory location of selector. Meaning that selector must be declared above this, or else issues. Because typically programs go from top to bottom. So if you don't do that, issue. Okay, it's looking good. Liking how it's looking, but moment of truth. Can it even run, bro? Nice. An error. Go line 7, column 67. 7, column 67. What's the issue? Missing column or... Oh, yes. Forgot this. Save that. Run again. Ah, wonderful. What do I want to do? Ay. I need to give them options of what they want to do. How thoughtless of me. Okay, another print statement. But this time print line so that it prints this stuff in a new line. Maybe this one should be print line. Yeah. And now this one should be print. And then what will we be printing here? The choices. If it's A they select, what you'll do is to add. If it's B they select, all you'll do is subtract. If it's C they select, all you'll do is multiply. And if it's D they select, all they'll do is divide. Is that the case? Yeah. Okay, things are looking good, but there's something missing. I feel it. Yeah, we need to make this look a little prettier. So we need to print something again. What will we print? This, to show them, prompting them for input of what they're selecting. Next, change this to a print line. Next, to change this to actually print, not printing. Save. Run. Undefined typo. 7, line 7, print line, print line. Nice. So let's say I want to multiply. There we go. 12, 22, 264 with a percentage sign, because percentage signs are cool. Good. We can now say that the Go program is done. And all it took us is 64 lines. Imagine, and you have an entire calculator over there. And you can use this on pretty much any machine, no matter their operating system. It could be a Windows machine, a Linux machine, which other machines are there? Mac. Yeah, you can use it on all those. Now let's just beautify our code so that it appears more readable. Indentation is one way to do that, so that I can see, okay, stuff within this function, it starts here and ends there. Okay, nice. It's more appreciated when it's cleaner. So, yeah, make the code clean, real clean, cleaner than clean. Poetry 101. Yeah, save. And I think that's all for today. We'll get back to business with a lower version in another video. Thank you for watching.